What would we do? We don't have a reference to go off, but I think 2 to the power 6 is going to be the first term. What's the next term going to be? It's going to be 2 to the power, let's put it in brackets to get it right. 2 to the power 5 and x to the power of, well, 1. Well, what's the coefficient? 6, because it's that line of the Pascal's triangle, isn't it? So once again, 2 to the power of 4 x squared. That's correct, yeah. Oh, done that thing where I ran out of space again. Next one is 20, is it? Yes. 20, 2 to the power of 3 x to the power of 3. And then 20 again, 2 to the power of 2. Oh, x to the power of 4, and then 15 again.
Wait, there's 2 20s.
Is there 2 20s? I could be, I'm trying to remember it. It's back to 15, is it? Oh yeah, it's an odd number because it's 7. The 6, but there's 7 terms, yes, you're right. So it's back to 6, my mistake. 2 to the power of 1 and x to the power of 5. So it's just all the pattern really, isn't it? And then x to the power of 6 to finish off with. Okay, so that was your expansion. You can expand those terms individually. The next part, well, I suppose we might as well tidy it up a little bit. 2 to the power of 6 is something. 64, is it? Yeah. 64 plus 2 to the power of 5, 32, 160-ish. Is it 160? 192. 192. That is terrible calculations. 2 to the power of 4 then. 216? 40, that sounds better. X squared plus 80, 160 x cubed, is it? Yeah. And then I'm going to go on the next line, 4 times 60 x to the 4. And 12 x to the 5 plus x to the 6. Okay, so we're here, and that's it tidied up. Okay. Expansion. The second question was interesting. It says, hence find the value of 2.01. So there's a very important word here, hence. A good few of you just went, so it's power 6, just went, calculator, just put it in. Well, a few of you went like that. The idea behind this was to use this 2 plus x. So it's 2 plus something to the power of 6. Now, how do I split this up into 2 plus something?
2 plus 0.01.
Yeah, 2 plus 0.01 is 2.01. So this 0.01 can be the same as x then. And that's what they were looking at. So every time there's an x, I'm going to put in 0.01, and I should get the answer your calculator gives you. So let's try and do it without the calculator. I've seen these given as non-calculator questions, by the way.
Oh, really?
Yes. 64 plus, well, 192 times 0.1. Now, 0.01 is quite nice because it's just 100th, isn't it? Which means dividing by 100, which is easy to do, isn't it? I think it is. Anyway, so let's just go through the line of just putting 0.01 in, just for, and if you're watching this, just skip on. If you're watching this later. 0.1 to the power of 5 was, 0.01 to the power of 6. Oh, geez. Okay, I'm going to put the answers up here. And I know that each one of these is going to be numerical in value, yeah? So that means I can just add them as I go. So the first number is 64. The second number is 192 multiplied by 0.01. That means just moving the decimal place 2 spots divided by 100, yeah? So that'd be 1.92 be the next thing to add on. I've done that one, I've done that one. 0.01 squared. 0.01 times itself. Oh, this pen. I need to refresh my pens. 0.01 times itself. It's going to end in 1 anyway. How many zeros after the decimal point?
2. No.
3, yeah. If you're setting up a multiplication with 4 after the decimal point, 4 digits after the decimal point, your answer is going to have 4 digits after the decimal point, after you multiply. So it's going to end up like this. 3. You could do it 100 multiplied by 100. So many zeros do you have? 4. Many points after the decimal place? 4. Okay. Could set it like that. That times 240. So 0.0240. That's that term back. Cubed. Well, that's okay now, because you just multiply this by 0.1. In other words, divide this by 100. If I were to divide it by 10, I put in 1 extra 0. If I divide by 100, I put in 2 extra zeros. So it's this many. This doesn't apply. This is now that. Okay. I multiply by 160. So the 160 goes 160. So it's 3 zeros and 160. 1, 2, 3, 160. What's that one done? Now, getting less and less significant, these figures, aren't they? So if I do it again, there's a couple of zeros. Oh, jeez. Multiplied by 60. So the 60 goes here. So 0.0000000. 1, 2, 3, 4, 5, 6, and then. Okay. That was 4 times. Now do another time. I'm just going to put it in here. 001. Oh. Does it say around this at any stage? No. So that's now going to be 12 here. 12 here. How many zeros? 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 0. That's that one dealt with. And then the last one's going to have, I'll put in another 001. A load of zeros. Something like that. Okay, I've lost interest in it. 61, 2. Oh, have I lined this up okay? There's a possibility I've got this wrong. 61144.9.65.
Yeah, that's what the calculator.
That's what the calculator says. Thank goodness. Okay, something like that. You have the calculator, just divide, you can just type that in and you get the term and then add it. If you just type that whole line in, you get it on the calculator. It didn't specify a non-calculator question, but I've seen them given, but usually not this many terms, usually like 4 terms. But the same question does come up a lot. So you have to be able to deal with that. This hence means you have to use binomial theorem to solve it, a hence like that. Okay, so if you do see hence. I think the rest of them seem to be okay, so we'll move along to something called factorial notation. After we think about this. Think about it, don't need to answer it yet. So I hope you guys didn't take, well, you could have taken it down, but get rid of it. Okay, so here's a problem. And this is more like the kind of problem you'll see in the exam setting. Find the 7th term, a specific term number, rather than expanding the whole thing. How many terms would be in the whole expansion if it's the power of 14? There'd be 15 terms, yes. Okay. Find the 7th one. That's kind of around the middle. We need, that coefficient's going to be difficult, isn't it? Because we're going to go, if you could draw Pascal's triangle and get the whole way down, but you'd be probably all the way, a long time getting there. So we need to have a method of finding that coefficient. What do we think? The 3x. So this is 3x minus 4 over x squared to the 14. We'll come back to this question hopefully at the end. But what do we think the x, this term is going to be multiplied by? Because it's going to be 3x to the power of something, and it's going to be 4 over x squared, or minus 4 over x squared to the power of something. These two, and we filled in, we need some coefficient here on the 7th term. What do you think this one's going to be? Well, we know something. We know the first term is going to be 3x to the power of 14, don't we? Probably do so. And we know that the first term of this is going to be to the power of 0. So what do we think this one's going to be? 6 or 7 is a good guess, yeah. What are we going to go for, 6 or 7? Both 6 and... This one's going to be 6 or 7. We're just going to write 6 stroke 7 when we won't decide. Come on, let's get off the fence and pick one. 7. Can we start counting at 0?
6.
So the 7th term, remember the first one of these doesn't exist, it's 0. So the first term is 0, the second term is 1. 6.
And the other one is 7.
This one's going to be 7 then?
Yes.
You sure?
Yes.
You're wrong.
Excellent.
The first term is x 3x to the 14, and the other one is to the 0. The second term is 13 and 1. Next term is 12 and 2. What are they always adding to? No. 14.
So
6 and 8.
8. Yes. So they always add to this one. And you can check that in any other one you've done for homework. These two should always add to that. Otherwise, you forgot one of the brackets. If you were to multiply this out, you have to write it 14 times. Yes? Why is this 6? If we notice, in any of our expansions, the b term, so a, let's go back to just a simple one, a plus b cubed, which is one of the ones we looked at. That's a cubed plus, and it was a squared b, and there's a coefficient here, we'll worry about that in a second, plus a1 b squared plus b cubed. It was something like that, wasn't it? The first term didn't have one, the b here. But you could write it in b0, b1, because it starts at 0 counting. So in the 7th term, which we're trying to find here, if you start at 0, 0, 1, 2, 3, 4, 5, 6, but I've counted 7 things. So I'm 1 behind. So in other words, if this was an n, like any number, what would this be? That'd be n minus 1, whatever the power number. And what's this one? N plus 1? N minus 1? But this is n. That didn't make sense. No.
whatever the term
Whatever the term number is. So this is not n anymore. We have to redefine n. So if n is the term number,
yeah.
not the exponent. Okay, well that's a better definition. N minus 1 then works because this is the 7th term, remember? And this then you're saying is n plus 1. Okay, maybe. Okay, does that work here? Just make sure that works. So this is the first term, the second term, the third term, and the fourth term. Let's just take the second term, for example. Is this n minus 1? Yes.
For the next.
Works for the next one?
No, it doesn't work for the 2. Because 2 plus 1 is
2 plus 1 is 3. 2 plus 1 is 3, yeah. Not sure that always works, does it? So there's plenty of issues here, but we're getting close. Perhaps we forget about the term number for a second, and let's just focus our mind on the coefficient. Any guesses about how big this number might be? In the hundreds? Yeah, it's going to be pretty big. It's going to be a pretty big number. This is right in the middle of that Pascal's triangle. And that's what we need this thing called factorial notation to find. So we're going to pause this one and we come back to this question as we go look at factorials and come back to that later on. Hopefully we'll get to back in the lesson. So let's look at factorials. Oh, this looks difficult. Have you seen it before, anyone? This exclamation mark in maths? No, okay. Very simple theory. 3 factorial, exclamation mark stands for the factorial, is a repeated multiplication. 3 times 2 times 1. That's it. It tells you where to start and just keep multiplying the number below it. One less until you get to 1. And it has a value, of course, 6. 3 times 2 is 6 times 1 is 6. That means 5 factorial can be found. 5 times 3 times 2 times 3 times 4 times 3 times 2 times 1. What's that?
60.
No.
1,
120. 120? 120. Very good. That is the whole factorial. That is it. You just keep multiplying number below. Now what you see and you see on the board is that can be represented with n's, with unknowns. So what if we wanted to find n factorial, let's say it's 100, what would be the first term you multiply by? 100, isn't it? The n times the next term would be 100, take away 1, 99, or in this case, n minus 1. And then n minus 2, all the way down till you end up with 2 and 1 again. So that's the general term for it. Whatever you start with that number. So 5, start with 5, just take away 1, multiply it. Take away another 1, multiply it until you end up at 1. And that's the general term, and that's what you see there. And this exclamation point is called factorial. Okay. Why is this important? It helps us find that first coefficient. Not quite yet, though. Let's look at these questions. Express in factorial form. Well, the first one doesn't have a... If you go 9 times 8 times 7, it doesn't have the rest of the factorial there. There's something wrong. So what do we do? Panic? Finish it? Okay, well let's look at this example again. What happens if we divide this and this? 5 factorial divided by 3 factorial. Well, we kind of know. 120 divided by 6, 20. Okay. How can that look differently? How can we simplify it before we do it? 5 factorial, we have it written up here. 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1. Yeah. There's no point in multiplying by this and then dividing by the same thing, and we just end up with 5 times 4. So it takes off the tail end. So now let's look at this. Express that in factorials and use division. What must go on top of the fraction? In this case, it was 5 factorial, because I want to start with 5 going all the way down. So let me start you off. 9 factorial is on top of the fraction because 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Over 6 factorial, because it will get rid of everything from 6 down. That's cancelled out that, and we're left with this. So another way to represent these 3 numbers multiplied, and this they have never seen before, is 9 factorial divided by 6 factorial. Is the same answer as 9 times 8 times 7. So that is that first question expressed in factorial form. Ooh, what about the second one?
Times maybe?
Yeah, you're gonna need, there's a bit missing in the middle or something. It's gonna have 11 factorial probably in it somewhere, maybe. Experiment. You do it. Experiment. It's going to be something like this. Something will cancel out with something. Maybe you need to put in an extra factorial that you didn't last time. What are you going to need to divide by? If you just divide by 7 factorial, it'll get rid of the top bit, but you need something else. Maybe you have to divide by 2 things put together. Try writing it. So there's definitely an 11 factorial somewhere. 4 factorial. Yeah, that will just need, yeah, almost. 4 factorial is a good guess. I see people writing 4 factorial down. That's going to need to be in there because it is in there. And other people are writing 7 factorial down, which is also in there. Because you need to get rid of the 11. Perhaps you need all those things. Perhaps you need 11 factorial, 7 factorial, and 4 factorial in the same problem. They could, if the question didn't ask it, express in factorial form only.
So can you theoretically do 11 factorial divided by 7 factorial divided by 4 factorial?
Yeah, you could, but I wouldn't write it like that. I know what you're thinking. You're thinking the right thing, but you've written it where you're at that and then ended up multiplying by the 11 factorial. A division of a division like that. So that's like saying, what is your pen? That's like saying half divided by 3, which is a half multiplied by 1 over 3. That's not what you want. You want the 3 here. So just put it there.
So you just switch them.
No, you put the 7 and 4 on the same line. Or you've written the same thing. Yeah. Well, you're off. The trust exercise. I can't wait.
It'll be great, you know.
It would be a great email.
Yeah.
Better be. Julian has more important things to do than his maths. Okay. No one's got it, but the 11, 7, and 4 need to be put into 1. Does anyone else want to show me think they got it? A couple of people are pretty close. This area is kind of close. This is, yeah. Why did you separate them like that? Put them all as one fraction. Yeah. It's difficult because this is a new concept to you. 11 factorial is on top. Yes. Something is on the bottom. 11 factorial is this. If I divide this by 7 factorial, what happens? Okay, that happens. What do we need back in the divisor? 4 factorial. So why don't we just multiply by 4 factorial as well?
Oh my God.
Of course!
Yo.
Okay, now we have it. That's it. That's it. This fits into this once. If you want to put the 1 there, yeah. We're left with that and that, which is what we want. Oh, we don't want the 7, do we? No, we don't want the 7. 7's cancelled. That. It's the same as, they're just numbers. This is just a number. It's just split up into multiplication. But yeah, that's it. That's how we represent this. They're the same. But interestingly enough, 11 factorial does not equal 7 factorial times 4 factorial, does it? You can see that. Otherwise, the answer would be 1. The 11 factorial is a huge number. 11 times 10 times 9 times 8. It's like in the thousands. Whereas this number doesn't quite match that. You can see that now. So the factorials have interesting operations. My advice, if there's factorials, is to split them up like this. So you see exactly what they are, and then bits will cancel out. Okay, I think the answers to these. I hope we got them right anyway. Or here somewhere. Yes. I did 4 and 7, but 7 and 4 is all good. Right. Here are some questions. I think ignore question 1. Do question 2, maybe the last question. I think you're well set up to do question 2I. If that's scary, maybe try one of the easier ones, but I think 2I is a good one to do. And then 3F, and then all of question 4, in theory. So we're looking at question 2, the last part, question 3, the last part. And
You want us to do 3 after that calculator?
that's what it says. Yeah, yeah.
Like just the last one?
Yeah, just the last one of 3, the last one of 2, the last one of 3, and all of 4. So the last one of 2 is very similar to this. So that
Does the bottom always add up to what's at the top?
no, it just happened this time. Yep. You see that?
Sort of. The number, the last one will be a bit hard.
Okay. That better?
Yeah, could you move it a bit back?
Sorry?
Could you move it a bit back?
A little bit left. I think my left is your right. We're only doing this question, and these 3. So you need to see that. There you go.
Okay,
Yes.
thank you.
Very good.
50 over 10 and 5.
Yeah. From 98, it's going
Yeah.
Because like 11, the 10, I
Yeah. Because, yeah.
Because all of this goes to 0. Sarah, I have no idea how.
No idea.
No, for F.
3F. Well, what you could do is multiply 100 by 99 by 98 by 97 by 96 in your head. Probably not a good idea. But you know what, at some stage you're going to divide by 98, 97, 96, 95. So maybe some of that might cancel.
Wouldn't none of it be variable?
None of it?
100 minus 98 is 2.
100 minus 98 is 2. Yes, that's correct. But you are just referring to this as 100, not what it is.
Is it 101?
101?
Okay, no.
This is 100 multiplied by 99, multiplied by 98, multiplied by 97, multiplied by 96, and so on.
100 times 99. I don't want to do it.
Oh.
You don't want to do 100 times 99. Something times 100.
Oh my God.
Just-
9,000.
Yes, multiply by 100.
Is this right?
I will check. Which one are you doing?
Yeah.
That looks better.
Okay.
Now that's pretty easy to do. Yes.
Which one's on 4?
All of them. Now, this is when it's theoretical can you do it. Most of you seem to be able to do it with 100,900.
4,900.
Yeah, that's right for the first one, yeah. So 100 times 9, 98, 4,000.
Wait, Sarah, this is 9.
Okay.
It is 15 factorial divided.
But you have
Just write it whatever. Teacher did 15 factorial divided. Just write 10 and 5 together. One next to it. 10 factorial divided by 5.
9,900 divided by
Wait,
2.
is this right? Something like that?
What?
Yep, that's it.
You didn't do long division,
Just-
it's just a waste of time.
And all questions
The
forward.
extra mile on
No, it's a simple.
What'd you get for 3 last?
Yes, without a calculator. You have to do.
So what's-
Mine again. No, I could be wrong.
what's
What is 2 times 1?
9,900.
Okay.
No, no,
So you can probably simplify that. Now,
Yeah.
100 times 9.
Yeah, but it's 9,900.
And then divide that by 2 without a calculator.
45.
Oh, simple math.
should be able to divide that by a calculator.
Oh my god.
4,950.
Yeah, that's what we see it go on our calculator.
Yeah.
Oh, that's cheap.
I could have done long division.
Just refer to the question and this line here. You know, just.
Oh, is it 4,900? Oh, wait. 4,900.
Did you have a breakdown in the middle of the word? Yes. It's 4,000 and something.
4,950.
That sounds right. That sounds right. Some of us did it on a calculator. Other people did.
That's not what I got.
What'd you get?
Technically, one of us did on a calculator.
Oh.
I wouldn't.
I wonder.
Yes, your method is obviously correct, but you just divided by 2 incorrectly. It's not 900 divided by. We went with that. 2 fits into that twice.
Okay.
Carry the 1.
Are you kidding?
2 fits into 19 then.
Oh,
Oh, carry the 1.
99 and then 100, right? Yeah, and then you just put 199 as the, is that the denominator? No, that's the numerator. And then you do 1 and 2 at the bottom. No, I'm still thinking about it.
I don't want it. I mean.
Okay, I think most people got the first one right. So it's going to be 15 factorial, so 2i. It's going to be 15 factorial. Is it 10 factorial, 5 factorial?
Yeah.
Yes, that's correct. 3f. Yeah, it's 100 times 99 times 98 times 97, all the way down. And the other one is 98 times 97 times all the way down. But you notice this all the way down is the same here as here, so they will just cancel each other out. And you're just left with, on the other side, so it was all the way down to 2 times 1, 2 times 1, that all cancelled out. But then you have an extra 2 factorial, which is 2 times 1.
Yeah.
So this would simplify down into 100 times 99 divided by 2 times 1. And now it's just figure it out without a calculator task. So 100 times 99 is 9,900, and then divided by 2. So it's 4,950. Now the ones in theory, anyone get an answer to any of the ones in theory? Start to forget it. It's way nicer just dealing with numbers, isn't it? This letter stuff. Oh, unfortunately. Just n?
Yeah.
Could be. Anyone else have a theory on this one?
Actually, yeah, you're right.
Just n?
Yeah, I think it's fine.
Just n sounds good. N factorial divided by n take away 1 factorial. N factorial is n multiplied by the next one down, n minus 1.
Oh my god.
Multiplied by n minus 2, all the way down to 1.
She knows how to think about
She sure does. N minus 1 factorial starts at n minus 1. And you take 1 away from that, so it's n minus 2. All the way down. But everything here cancels with everything there, and we're left with n. N is the answer. All right, do the other 2 now. Same process. Start by expanding, and you'll see things will cancel out.
For the next term of that one, would it be n plus 3?
Next term, this one?
7, 4.
Oh, no, it'd be n plus 1. Take away 1. So remember, 9 factorial is 9, then 8, then 7, not 9, then 10, then 11. It goes down. So you've got to subtract 1 from n plus 2. Yeah.
N
But you have to
plus.
subtract one from n plus two.
So what's the 1 less than n plus 2? N plus 1. And 1. You got an answer? Let's see.
C. Three. Sure. Add.
Oh,
N plus 1, is that divided by n plus 2 or just? Yes. So you would have to multiply that.
Wait, so is it this?
Expand it. Yes. Boom. Nice. Why is it n plus 3 next? You know it's factorial, it always goes down. You've gone up one. Yes. Down. Otherwise it will go to infinity and be infinity. Be huge number. As in, the first one after n plus 2 is going to be n plus 1. Yes, that's correct. But your multiplication is dodgy. N times n is that's n squared. Yeah. So it's correct by the multiplication.
Wait, I don't know.
Oh, for that one? It'd be n plus 1. Yeah, that's it. Yeah, good stuff. Okay, so let's get to the answers due to time constraints. We'll move on. So the next one would be n plus 2 factorial divided by n factorial. N plus 2 factorial is this. Multiplied by n. Here's an interesting way of rewriting what I write up here. See what I did? Instead of writing the dots, I just know from then on it is n factorial. And n factorial will cancel out with n factorial. I didn't have to write all that out. You can if you want, but I didn't have to. This multiplied out gives n squared plus 3n plus 2. The next. You're off.
Wait, but is that?
Way too early.
Uh-oh.
Oh, yeah. Yep.
Isn't there another n?
Isn't there another n?
Or,
This one?
but is n factorial, does that start with n, or does it start with n minus 1? Oh, it starts with n.
Yes,
Okay.
you've answered correctly, yeah. Okay, and the last one, n plus 1 factorial divided by n minus 1 factorial. This one is n plus 1. The next term then is 1 less than that, so that's just n, isn't it? Multiplied by n minus 1, and it goes on, or I can just write factorial, all over n minus 1 factorial. I didn't need to expand those again, because once again, that cancelled that. Now we're left with n squared plus n, when I multiply these two. Okay, this has not helped us solve what we were trying to solve, what we were trying to do at the start.
Something.
Figure the coefficient.
Coefficient on binomial theorem, this just seems like I've gone way off the tangent. I kind of have, but I kind of haven't. This leads us to this NCOR principle. Yeah. Already sounds complicated. It's on your, this looks horrible. It's not too bad. It's from something called permutations, combinations, which is counting principles, actually on the HL course, but not on your course. It's about possible combinations. And remember, when we were multiplying in the binomial theorem, we combinations. We put together 3 of that and 2 of that, or whatever it was, squared and cubed. This is dealing with that. This is a formula, this one is a formula for finding that coefficient of in the binomial, this thing here. What's R? What's N? What's R? R was what you were calling N earlier on. And N is what I was calling N. If we remember,
14.
the 14 and the 7, yeah, that's the N and the R. But luckily enough, this formula, sometimes you have to use it, is summed up with these on your calculator with this thing called NCR. So the formula, put it in your notes. It is given in your formula booklet, but we don't have one of those each yet. N factorial all over N take away R factorial multiplied by R factorial. Have that. That is the NCR. NCR is that. And that is the binomial coefficient. This clock is very fast, by the way. If you're thinking of flashing over. 4 minutes. Okay, so get out your calculators and I'll show you where it is. On your calculators. Hopefully you have your proper calculator today.
Mine's dead.
Okay.
Wait, can I write that down?
Yeah, have that in your notes, yeah. Because you will need to use it for non-calculator questions. You may. Or you could use the Pascal's triangle. All right, so on the calculator. All right, so I'll show it to this screen, and you can watch it later. If you go, and I'll talk you through it, if you go to math on your calculator, and then move over to the probability section, which is the last section. You could probably see it as the third option, NCR. If you go to math, probability section, and you go to NCR. That is it. So, if we do a simple example, I'll start again. We're going to do 5 NCR 3. So press 5. If you have a calculator, which a couple of you do. Go then to math. Scroll across to probability. Press N. Oh, I did the wrong one. 5, math, probability, NCR. Press enter. It comes up on your calculator 3. So when you do it, you should see that. And press equals. You should see this. That's what you will see. 5, and then press equals. Or you can have that there. Don't have the instructions for that one. And then you press equals, and what do you get? You get 10.
Wait, what number did you say?
I did 5, and I pressed NCR button 3. So you just type it in 5, NCR button 3, and the answer to that is 10. And the last thing we're going to do is see, using the formula, do we get 10? So N is 5, or is 3. So we're going to do it with the calculator. N is 5 factorial. N take away or is 5 minus 3 factorial, and multiply it by 3 factorial. 5 take away 3 is 2. Okay, I've done the top line out. 5 factorial. 5 minus 3 factorial is 2 factorial, which is 2 times 1. And that's multiplied by 3, which is 3 times 2 times 1. 3 times 2 times 1, cancel 3 times 2 times 1. If you want, the 2 divides into the 4 twice, and we're left with 5 times 2, which is 10. But your calculator will do that formula out for you. This formula will help you find the coefficient. Now, we didn't get to that question, but if you have something like our question, the 14th term and the 7th. It's got something to do with putting 14 here and 7, typing in your calculator, and it will churn out that number in Pascal's term for you. So we'll get to that next week. There will be a small bit of homework, not much, due on Monday. Not much because we didn't quite get to as far as we want to. So check that out and manage back and have it done for Monday's class. And that is us.